From the simple heat and ventilation systems found on classic Buicks to modern air conditioning systems, Buick has continuously refined climate control in order to assure owners of the most comfortable automobiles on the American road. Buick's automatic climate control system is a sophisticated system that adjusts vehicle interior temperature to a value selected on the control assembly. When people think of an automatic temperature maintenance system, they usually recall a home heating or cooling system. But Buick's automatic climate control differs in operation from a home heating and cooling system. A home system cycles on and off. The home system delivers bursts of warm air when heat is required or cool air when air conditioning is required. Buick's automatic climate control system does not produce bursts of hot or cold air. Instead, the automatic climate control runs all the time. Automatic climate control constantly monitors outside and inside temperatures and adjusts vent output temperature to best achieve the value selected by the operator. The C68 and CJ2 systems can be used as partially automatic climate control systems or as fully automatic interior climate control systems. In automatic mode, the driver merely selects a temperature between 65 and 85 degrees. The automatic climate control system adjusts the air valves and the temperature valves to maintain the selected values. It also controls compressor clutch engagement and, when the blower is in automatic mode, blower speed to reach and maintain the desired temperature. Depending on the value desired, air is automatically sent to the heater outlets, the heater and defroster outlets, the panel outlets, or the floor and panel outlets. When a temperature of 65 degrees is selected and the cool button is touched, the system goes to maximum cool. 60 degrees appears on the display, and the system cools to the coolest air delivery possible. In the same manner, if 85 degrees is selected and the warm button is pushed again, 90 degrees appears on the display, and the system produces maximum heat until another temperature setting is selected. Besides the automatic mode, other modes can be selected. For example, when defrost is selected, air is sent to the defroster outlets. But defroster operation varies depending on vehicle. When defrost is selected on the Park Avenue, LeSabre, or Riviera, air is directed to the defroster outlets. The compressor clutch engages and the system adjusts air temperature so that it reaches and then maintains the selected in-car temperature. When defrost is selected on the Roadmaster, airflow is directed to the defroster outlets while the temperature valve moves to full warm and the blower runs at full speed. Blower speed can be manually adjusted to a lower speed. The Riviera and LeSabre feature another automatic mode, bi-level. In bi-level, the compressor operates as required and the air temperature valve automatically moves to reach and then maintain the selected in-car temperature. Air flows through the floor and panel outlets. Standard on the Ultra and an option on the Park Avenue is dual zone climate control. Dual zone is also an automatic climate mode. It differs from other automatic systems in that dual zone contains two air temperature valves. One valve regulates air temperature to the driver's side and one regulates air temperature to the passenger side of the vehicle. Using a push-button control, the passenger can select a temperature that is cooler or warmer than the temperature the driver has selected. The climate control system automatically adjusts the second set of temperature valves so that air sent to the passenger side outlets matches the passenger setting. ECON is a partially automatic mode. When economy is selected, the climate control system works as it does in automatic mode, only without cooling. The compressor does not engage. Without compressor engagement, the climate control system cannot cool the car colder than the outside temperature. Nevertheless, the system still tries to reach and maintain the selected temperature. Air is directed to the panel outlets. Heater is also a partially automatic mode. When heater is selected, the system adjusts the air temperature valve to maintain and reach the selected in-car temperature. The compressor does not engage. When heater is selected, most of the air flows from the heater outlets. When off is selected, the system continues to operate in a partially automatic mode. In off, all air flows to the heater outlets. In off, neither the compressor nor the blower run. Nevertheless, the system still works toward reaching the selected temperature. For example, if 70 degrees is selected and it is a cold day, the system adjusts the temperature valve so that the car may eventually reach the 70-degree temperature, but without the blower pushing heated air into the vehicle. A microprocessor is used to automatically adjust interior temperature. The microprocessor gathers information from various sensors. The microprocessor then uses this information to control blower speed, compressor engagement, output air temperature, and to direct air delivery to the vents. On the systems found in the LeSabre and Roadmaster, the microprocessor is contained in the electronic control assembly. The microprocessor directs a programmer. The programmer supplies the muscle to adjust temperature. The programmer converts electrical signals from the microprocessor into vacuum commands for the actuators in the air distribution assembly. On the Park Avenue, the programmer contains the microprocessor and makes the physical adjustments necessary to change temperature. The electronic control assembly signals the operator's desires to the microprocessor. The microprocessor then directs the programmer to adjust the appropriate valves to reach and maintain the selected temperature. On the Riviera, the electronic control assembly signals the body control module. The microprocessor in the BCM directs the programmer. Microprocessor location is not important to automatic control of passenger compartment temperature. It is important, however, for the microprocessor to know outside and inside temperatures. An outside air temperature sensor is located on the upper radiator tie bar. The outside air temperature sensor is a thermistor whose resistance varies inversely with temperature. The greater the temperature, the less the resistance. Resistance varies from over 100,000 ohms at minus 40 degrees to less than 2,000 ohms at 95 degrees. The electronic control assembly, programmer, or BCM, supplies a 5-volt reference voltage to the sensor. By measuring the voltage in the sensor circuit, the microprocessor obtains a temperature signal. City driving with long periods of idling tends to heat up the sensor and provide a false reading. On the Riviera, for example, to compensate for high temperatures around the radiator when the vehicle is traveling at speeds less than 20 miles per hour, the microprocessor limits the outside temperature value to an increase of 2 degrees every 100 seconds. At speeds between 20 and 45 miles per hour, there is a 2-minute delay, after which the temperature value is allowed to increase as necessary. At speeds above 45 miles per hour, there is no delay, and the outside temperature reading is used immediately by the microprocessor. Like the outside temperature sensor, the inside air temperature sensor is also a temperature-sensitive thermistor. The inside air temperature sensor is mounted under the dash inside a short horizontal tube. The tube connects to an aspirator duct just upstream from the evaporator. When the blower runs, air flows through the air delivery module. As the air moves through the air delivery module, a stream of inside air is drawn through the aspirator duct and past the inside air temperature sensor. This air movement makes the accuracy of the sensor possible. In addition, the Roadmaster and Riviera have a sunload sensor. The Park Avenue has two sunload sensors, one on each side of the vehicle. Sunload sensors respond to varying degrees of sunlight. The microprocessor takes the sunload value and compares it to the in-car temperature to determine how much cooling or heating is necessary to maintain the selected interior temperature. The effect of the sunload sensor in bright sunlight is the same as lowering the temperature setting by as much as 3 degrees. After learning outside and inside temperatures and, except for the LeSabre, measuring sun effect, the microprocessor signals the programmer to change the position of the air distribution valves. The programmer energizes the appropriate solenoid to reposition the appropriate air distribution valve. The microprocessor also controls blower operation to obtain the selected passenger compartment temperature. The microprocessor controls blower speed through the blower power module. The blower power module is located on top of the evaporator assembly. Attached to the power module, a large heat sink protrudes into the evaporator airstream to dissipate heat. In automatic mode, the microprocessor commands the power module to run the blower at any one of 10 speeds on the Roadmaster and an infinite number of speeds on the Park Avenue, LeSabre, and Riviera. Low and high blower speeds can also be chosen manually. Besides adjusting blower speed, the microprocessor uses sensor information to adjust the valves in the air delivery module. Air drawn into the air delivery module can come from inside or outside the vehicle. The air is recirculated only when maximum air conditioning is required or when the system is in auto and the temperature is set at 90 degrees. The Riviera and LeSabre use air delivery modules which are similar. The Park Avenue, with the dual zone system, features a second temperature valve to regulate passenger side temperature. Still, the configurations are similar. On the Park Avenue, LeSabre, and Riviera, the mode valve directs air to the heater outlets or to the panel and defroster outlets. The mode valve is operated by a bidirectional vacuum actuator, allowing for 3 valve positions. At rest, with no vacuum applied to either side of the actuator, springs in the actuator move the valve to mid-position B. In mid-position, air flows through the defroster and heater outlets. When the programmer directs vacuum to the heater side of the actuator, the mode valve moves to position C, and air is directed to the heater outlets. In the same manner, when the microprocessor senses the need for cooling, the programmer directs vacuum to the AC side of the mode actuator. The valve moves to position A, sending air to the defrost AC valve. The defrost AC valve determines whether air is directed to the defroster outlets or the panel outlets. With no vacuum supplied to the defrost AC actuator, the valve moves to position A and air flows to the defroster outlets. When the system senses the need for cooling, vacuum is applied to the defrost AC actuator. The defrost AC valve moves to position B and air flows from the panel outlets. The placement of the air delivery valves in the Roadmaster differs slightly from the other models. The mode valve directs air to the panel outlets and the heater defrost valve. The mode valve is controlled by a bidirectional actuator. When no vacuum is applied to the actuator, the valve moves to position B, and air flows through the panel outlets and to the heater defrost valve. When the system senses the need for more cooling, vacuum is applied to the AC side of the actuator. The mode valve moves to position A, and air flows to the panel outlets. When the system senses the need for more heat or defrost, vacuum is applied to the heater side of the actuator, moving the mode valve to position C. Air is directed to the heater defrost valve. The heater defrost valve sends air through either the heater outlets or the defroster outlets. With no vacuum applied to the actuator, the heater defrost valve moves to position A, the defrost position. Air flows through the defroster outlets. When the heater defrost actuator is energized, the valve moves to position B, directing air to the heater outlets. The Roadmaster has an additional valve, the heater water valve. With no vacuum applied to the heater water actuator, coolant flows through the heater core. When an air conditioning mode such as automatic is selected and the temperature setting requires cooling, the programmer applies vacuum to the heater water actuator, closing the heater water valve. The closed valve stops coolant flow through the heater core and permits maximum cooling from the evaporator. The air temperature valve is the only valve in the air delivery module that is not positioned by a vacuum actuator. Instead, the air temperature valve is controlled by a high-speed bidirectional motor. As the motor turns, it operates a crank arm with a plastic pivot. The plastic pivot allows door rod adjustment. Pivot rod adjustment is critical for accurate temperature control. Extreme weather conditions can limit the effectiveness of the climate control system. To offset these conditions and provide a comfortable environment, the microprocessor is programmed with a series of delays. Delays may differ depending on the model. See the know-how manual for delays relating to a specific vehicle. For example, if a Roadmaster has been parked in a hot sun with the windows closed, the interior air is generally warmer than the outside air. Signals from the inside and outside air temperature sensors alert the microprocessor that the interior air may have become superheated. So instead of recirculating the interior air in a normal maximum air conditioning mode, the microprocessor initiates an air recirculation delay. The microprocessor adjusts the air recirculating valve to use the relatively cooler outside air for initial circulation. Only after the delay has ended and the interior air has cooled enough to contribute to further cool down does the microprocessor close the air recirculation valve. At the other extreme, there is the cold weather delay. During a cold start in cold weather, warm moisture from the breath of vehicle occupants may condense as frost or fog on the windshield. In auto mode, when conditions exist to cause frost or fog, the microprocessor initiates a delay program which sets the air valves to deliver airflow to the windshield through the defroster outlets. The blower switches to low speed. When engine temperature reaches 95 degrees, or after a 4-minute delay, the climate control system reverts to its normal operating mode. Cold weather and snow can create other problems for a climate-controlled system. During startup in cold weather, snow can be drawn into the climate-controlled system through the outside air recirculating valve. This happens when the air valves are in the defrost mode and the blower speed is in high. To prevent snow from being drawn into the air delivery module, a defrost high blower delay is programmed into the microprocessor. When outside temperature is below 24 degrees, power to the blower motor is limited to 8 volts in the defrost mode. Once engine coolant temperature exceeds 90 degrees, the system returns to the previous setting. At the other end of the spectrum, warm, humid days create other problems. During a startup with a still warm engine, humid air which collects around the heater core inside the air delivery module can fog the windshield if blown through the defroster outlets. To prevent fogging, a purge routine is programmed into the microprocessor. With coolant temperature at least 60 degrees and the blower in automatic, the mode valve directs air away from the defroster outlets. And during the first 5 seconds of operation, the blower does not run. Then, for the next 15 seconds, the blower runs at low speed, purging moist air from the system. After that, the system returns to its normal operating mode. Frequently, delays and purges are mistaken for system malfunctions. While the microprocessor can be used to diagnose system problems, the first step in diagnosing automatic climate control problems remains the System Check Normal Operation chart. Performing the System Check Normal Operation procedure verifies system operation. If the System Check Normal Operation does not locate a system fault, access the Self-Diagnostic feature. Faults in the temperature sensor circuits and temperature valve control circuit are identified when the electronic microprocessor operates in diagnostic mode. While the BCM on the Riviera Reatta can access codes from other system computers, the microprocessors used in the LeSabre, Park Avenue, and Roadmaster access only climate control codes. Nevertheless, PCM-ECM codes should be checked for a problem that may affect climate control operation. If a fault has been detected on the LeSabre, the external temperature display flashes during the first few seconds of operation. Fault codes on the LeSabre are displayed by turning the ignition to run and pressing the hidden button between the heater and external temperature buttons. A fault code number appears on the temperature display. As on the LeSabre, the temperature indicator on the Park Avenue flashes during the first few minutes of operation if the microprocessor has detected a fault. To enter diagnostic mode, press the off and warm buttons simultaneously. Besides displaying codes, the Park Avenue's onboard diagnostics can be used to display system data and to command the programmer to override commands. Overriding commands makes verification of repairs easier. For example, if an outside air temperature sensor has been replaced by using the override feature, the new ambient temperature is displayed on the control head, not the old one stored in memory. On the Roadmaster, the display flashes when a fault has been discovered. If the microprocessor has a fault stored in memory, it flashes the FC symbol to the right of the temperature indicator. To enter diagnostics on the Roadmaster, press and hold the external temperature and off switch until the fault codes are displayed on the LCD. By pressing the external temperature switch again, climate control data is displayed. To view the data list, press the fan up or fan down switch. Once the data to be checked has been chosen, press the auto switch. A diagnostic value is displayed in the LCD. On the Riviera, climate control diagnostics are accessed through the body control module. To enter diagnostics, press and hold the off and warm buttons until all displays are lit. Proceed to the climate control system diagnostics by pressing fan down. Press bilevel to leave diagnostics. The system reverts back to the last climate control settings. From simple heat and ventilation systems found on classic Buicks to modern air conditioning systems, Buick has continuously refined climate control. Buick's automatic climate control systems cool or heat the vehicle interior to the selected temperature no matter where the vehicle is driven. Whatever the conditions, automatic climate control maintains the selected temperature to assure Buick owners the most comfortable automobiles on the American road.